Hi, students. This is Kyun. So in the last lecture, you have learned copy constructor, which is necessary to implement deep copying while you are using memory allocation. So because while you are using memory allocation, your destructor is deallocating it. But in that case, you have to perform a deep copy to prevent the anomaly of shallow copying. So the decoupling is a very important concept, especially for the container, such as vector and array. So let me just briefly review the material with an additional operator, which is called assignment operator. So actually the operator overloading was described in the overloading section, but it should be performed while you are in need the copy constructor. So let me share the screen before the explanation. So the overloading, the assignment operator is just a simple assignment operator here, described here. This is the assignment operator, as you know, but this is an accumulated assignment operator, composite assignment. So it is not handled automatically. So if you really need these operators, you have to overload them separately. So you have to overload plus assignment, minus assignment. So if you really need some of them. So in the last lecture, you have learned the constructors and destructors. So for the constructor, the destructor should deallocate an object. This is not especially needed for other classes, other objects, but it is in need for the container. So you have implemented a simple container, which is called stack, which is a default container, last in first out container. So in that case, you have to implement the copy constructor. The copy constructor has the prototype like this. It is a constructor of class C, but it accepts another object whose type is C. So for the case of a stack, you have to implement a copy constructor like this. Stack, this is a constructor, but it accepts const reference, const stack reference, S. Okay, so it has a special prototype, and this copy constructor is used when you build an object based on another object. So it is really neat when you allocate a container using a new or malloc. Okay. So this copy constructor should perform a deep copy. That is called a deep copy. So once you allocate an object like this, and without the copy constructor, it may be shared like this. This is called a shallow copy. But if you really need a container separately, you have to copy the allocated portion. This is called a deep copy. So this concept is extremely important, and programming because it is related to the safety. So as you know, so let me share the terminal. Okay, in any case, so this is the prototype of the copy constructor. So if you don't have a copy constructor, then you don't need this kind of declaration. Then it performs a shallow copy. So if you want to print a stack and push it and reverse print twice, then maybe a problem, okay? So let's just write this, and in your terminal, you may compile it, ++ reverse print 2, the CPP. In the current folder. So 1, 2, 3. Control. So any number is good. So it is aborted. So it prints fine at the first reverse print, but in the second reverse print, it is an error because the copy constructor is actually used here. So you are passing the stack, you are passing stack as a parameter. So once you like to print, reverse print just once, it is good. So G++, reverse print to the CPP, and you are executing it 1, 2, 3 without. So it seems good. It seems good at first, but it is not working here. Okay, it is not working here. Since you didn't use the copy constructor, because your stack is allocated with this new. Okay, so this is important for memory allocation. But you are destructing it memory deallocation. So it is incurred with this allocation and deallocation. So if you define a copy constructor with a deep copy, it seems good. It should be good. G++ reverse print to the CPP, executing it 1, 2, 3 dot, seems good. So it is also good for reverse print them twice, print it twice. So I have to G++ reverse print to the CPP, executing it 1, 2, 3 dot. So it seems good. Okay. So with the help of copy constructor. So what you learned today is the importance of copy constructor and the assignment operator. So reverse print after the assignment. So you'd like to print them twice. So you added stack T and reverse print numbers. It is assigned using this reverse print, but you know that this is not an assignment. It is called initialization. Even though it is using the assignment operator, this is different to the assignment. initialization is different to the assignment. So this is the same effect, stack T with S. Okay, so let me just test this with your current code. So if you want to reverse print twice, copying this with another stack T, but the stack T is created based on S. Okay, so it seems good. So let me just compile this. G++ reverse print to the CPP, executing it. So it is more friendly. It will produce more friendly output. 1, 2, 3, dot. So numbers in reverse is printed twice. It seems good. Okay, but this similar code using the assignment. So you are making this, making an empty stack. This is an empty stack. But you made an assignment. This is an assignment. So even though it seems similar to the previous code, it seems an error. Okay, so let me just test it. Even though it is very similar, is assigned with S, ++ reverse print to the CPP. So let me test it. 1, 2, 3, dot, aborted. So even if it is not aborted in your environment, it is not correct because the assignment operator does not perform the deep copying. Okay, so this is different. As you know, if you making it with this is an initialization. That means it is same to the copy constructor like this. Okay, so it is using the copy constructor. But if you are making a stack T and T is assigned by S, this is not using the copy constructor. It is using the assignment operator. So this is using the copy constructor. So it is same too, even if you are using this one. Okay, it is copy constructor. So for the assignment operator, you have to overload them. So how can I overload it? You may overload. It may return stack operator assignment, but it is accepting const stack reference S. Okay, this is the prototype of the assignment operator. So how can you do that? Just do the similar thing with the copy constructor like this. So 3 lines copied here. But you have to make a new stack, okay, new stack. So the data, actually the size of should be initialized as the size. And data is newly allocated, okay, and it should return myself. Okay. So with this simple modification, this is also good for the assignment operator. So let me just compile it. ++ reverse print to.cpp, executing it 1, 2, 3, dot. What's wrong? Numbers in reverse is not printed. So it seems that the copy assignment operator is performed wrongly. Top should be assigned. Okay. Top is s dot top. Okay. Top is not assigned properly. So let me just compile this again. Reverse print to.cpp, executing it. Sorry, my cell phone is replying to my lecture. 1, 2, 3. Okay, it seems good. Okay, so when you have to make a copy constructor, then you have to overload the assignment operator similarly. Okay, so let me just share your lecture note. It is printing the anomaly. So I said that this is a copy constructor call. This is since it is an initialization. But in this case, it is not the initialization since the declaration is called separately and you assigned it with the same stack object. Okay, so this is an assignment. So you want that similar code working similarly. So in that case, you have to overload the assignment operator, which is returning a const reference stack. So you may also safely use a const reference stack, okay? So this is not mandatory, but it is also good. So as you know, this is more safe. So if we already have a data, this is deallocated and it is initialized. Okay, so this is a more safer version. So let me share the code. Because my previous code is performing space leak. Okay, since it does not deallocate it. So if the data is allocated, then you can delete data. Okay, and this is also good for returning const stack reference, but do not copying that. Okay, so this is a more complete version. G++ reverse print to.cpp. So it is much like idiomatic. Okay, so you just follow the description. Okay, so it's much like an idiomatic pattern. Any questions up to here? No questions?
Can I look at the class function?
Okay. Tenges, do you have any question?
Yeah, I want to look at the class function.
The code?
Yes.
Okay. So let me just close this. So any questions on the code? So you may compare this with a copy constructor. So if I copy this, this is a copy constructor. This is actually destructor. So let me just make a destructor here. So this is your copy constructor. So compare them. Okay, they are very similar. Can guess what is your question?
I just wanted to see this because I didn't know what you were talking about.
Okay, so it is described in your lecture note. This is very similar to this, but it is very similar. As you know, this is a copy constructor. And this is an assignment operator. So you are overloading the assignment operator.
Professor, I have a question.
Kancharon, what is your question?
How is the private variable of S is accessed on copy constructing?
How can you access it?
The S dot top, and there is a private variable, right?
Okay.
And how can you access it?
Okay. So actually, in a strict manner, it should not be accessed. But as you know, this is a stack code. As you know, this is a member of a stack. So even though it is not private, it is not my private, but it is accessible, allowed in C++ in your member function. So your question is telling that it is the private of S. Is this right? Private of S. But since S is a type of a stack, so it is allowed in the stack member. So the constructor is the member, is considered as a member. So it is accessible. It is much like that. If I share this in your code, so you are accessing is full, is accessing the top and sides, which is private of a stack, okay? So it is allowed in your member function, in your constructor or in your member function. But if you decided this should not be performed as a member, that is not a good implementation, but it is still possible if you'd like to as a non-member, okay, operator, so it accepts another stack reference T. Since it is a non-member, in that case, this is an error. Okay, so T.data, and you have to delete the T.data, T.top, T.size, T.data is set as T.size, sorry, T.size. In this case, so you have to return T instead. This is not allowed. This is a compilation error because it is not a member. Okay, so let me just compile this for you. So G++ reverse print to the CPP. In that case, it is an error. So today's problem is associated with a copy constructor. So when you declare an instance of a class, a constructor is invoked. Yet there are lots of cases where the constructor of a class is invoked. You have seen an example of it as like an initialization. So you have seen the example, stack S is initialized D by T, then actually the copy constructor is called. Copy constructor is called. And it happens to be needed to construct an object based on another object, the same type. The copy constructor should be invoked. And as you can see in this simple example, you are making an integer. So when you're making an integer, you are printing it, making int. So when you are making an integer based on another integer, you are printing it with calling the copy constructor of int, okay, to tell the difference of it. And next, integer next is accepting an integer and making a next integer of it, okay? So let me test this. In your terminal. So you are making an integer. So this is a constructor call, but not a copy constructor because it is accepting an integer, another integer. So let me just share this. So what is a good name for this? So it should be written and exit this. So vi integer, so into the CPP. So you are making stream using namespace and std. So you're creating a class int whose private member, whose private member is int and but public functions for others int, accepting an integer n whose default parameter is 0. So you are making an annotation to the cout, making int with n line. So if you're calling a copy constructor, constant reference I, this is a call for copy constructor. So I.n, even though it is a private of I, it is accessible because this is a member. Calling the copy constructor, setter of int and underscore n is good. Line. And the value for integer is accessible by get. Return n. Okay. So you are making another function next of integer n is returning a new integer and that get +1. Main, creating an integer with number 3, initial value, another integer b, Next, A. So you get to know where the copy constructor is called. Oh, sorry. So make int. So you are making int 3. So the first call of int 3 is obviously with this int constructor is called. And you're calling the copy constructor of it. You are making next integer, maybe here, int n. So you're copying interceptor of a copying constructor. And in the second case here, this may be another place into copy constructor, but it is invoking the copy constructor just once because it is based on another integer object. So I think that the copy constructor is optimized at the second call. So if you don't have any question, let me describe today's problem. So do you have any questions up to now? Any more questions on the problems or contents of